Hello student, in last class we learnt about the reproductive system of both male and female. I hope you all understood about that male and female reproductive system. Today I am going to take few important points in human reproductive system, especially one by one, that is male and female reproductive system. First one, in male reproductive system. So once again we'll recall the points. So this is male reproductive system. So a pair of testes both the side. Then this is the detailed structure of the testes. So in this detailed structure you can find lot of lobule like structure. So these lobules will be having highly coiled seminiferous tubules. So it is single tube but is highly coiled, and these are called as seminiferous tubules, and this is the site of sperm production. And this seminiferous tubules are converged to form the tubulus rectus, and these tubulus rectus are united to form retitestes. And this retitestes is a network which is present posterior side of the, so this is anterior side and this is posterior side of the testes. So this retitestes is located posterior part of the testes. And next one, they converge to form the vasa efferentiate. So vasa efferentiate, the proximal one is called as vasa efferentiate, and later it is to be vasa deferens. So this is called as vasa efferentiata. And this vasa efferentiata, all the vasa efferentiates are united to form a tissue, highly coiled mass tissue is called as epididymis. So this is simple coiled tissue which stores the sperm temporarily, and the sperm matures here only, and its motility capacity increases here, and this area only increases the sperm's fertile capacity. So everything will be takes place inside. So once the sperm produced by the seminiferous tubules, it will be reaching the epididymis and stored here, and then it will attain all the characteristic feature, and then only from the epididymis it will be leaving and passing through the vasa deferens. So this is vasa deferens. It is straight tube like structure, long tube like structure. So this is a continuation of vasa deferens. So this vasa deferens of both the side, so both vasa deferens are connected to form a common duct. So here what happens, remaining vesicle gland and prostate gland and some other Cowper glands, everything is opening here, and this mixes with the sperm and forming the semen, and then it will leaving from the testes and reaching the urethra and passes out. So this is urethra, and this urethra is a common passage for urine as well as the sperm. And this about the male reproductive system, and these are the accessory associated male reproductive part, that is testes, retitestes, vasa efferentiata, epididymis and vasa deferens, everything. And next one is Sertoli cell. So this is nothing but it is otherwise called as nurse cell, which nurturing the sperm and giving nutrition for the sperm for the maturation. And this Sertoli cell is located inside the seminiferous tubule. While we taking a transverse section of seminiferous tubules, we can find this oval-like structure, a lot of circle-like structures. They are called as so these cells are called as Sertoli cells, and these Sertoli cell is the place of sperm production, and this will be synthesizing the sperm and releasing out, and this is called as from the Sertoli cell the sperm leaving and reaching the lumen, the center cavity. This process is called as spermiation, and after that what happens, it will enter through the remaining successive area of the male reproductive part. And next one, and this Sertoli cells having the capacity of feedback mechanism, that is by secreting inhibin. So this inhibin doing the feedback mechanism. Do you know what is feedback mechanism? Feedback mechanism means once the hormone, that is testosterone and follicle stimulating hormone or male reproductive hormone is secreted more, this inhibin will make the to stop secretion, or if the hormone is less or if the gland is less, this inhibin make the cell to secrete the hormones or glands. So that is called as feedback mechanism, that is maintained by the inhibin of the Sertoli cell only. And next one is interstitial cells or Leydig cells. So these interstitial cells are located between the ceratolase. Between this structure and one structures we can find the Leydig cells. So these Leydig cells is otherwise called as interstitial cells. So where it is located, it is embedded in the soft connective tissue that is surrounding the seminiferous tubules. So you know where is seminiferous tubules? These seminiferous tubules are located inside the testes, and that seminiferous tubule tissues are surrounded by the Leydig cells. So this Leydig cells having the special function that it will be the involvement in the secretion of androgen, namely testosterone hormone, and because of this involving in the process of spermatogenesis. So that is very important cell. The ceratolase cell is otherwise called as nurse cell, which will be nourishing the sperm, and Leydig cells is involving in the secretion of androgen, that is testosterone hormone, for spermatogenesis production. So this is a structure of ovary. So this is structure of ovary. The structure of ovary, the length of the ovary is 2 to 4 centimeter long, and it is covered by the cuboidal epithelium cells. So these are all cuboidal epithelium cells. So they are enclosed to form this structure is called as ovarian stroma. So this entire ovarian stroma is divided into two parts, that is internal and peripheral. So this peripheral area is called as cortex, and this area is called as medulla. This peripheral cortex is so dense because it having different stages of Graafian follicles, that is follicles, female follicles. So these female follicles are in different stages. So this is primary, that is primordial follicle, and this is primary follicle, secondary follicles, tertiary follicle, and matured follicle with oocyte, and this is corona radiata, that is a fully matured ova. Then ova will be released here, and here the rupturing due to the process of rupturing, and this is called as developing corpus luteum, that is after the ovulation this corpus luteum will be forming, and this corpus luteum is filled with progesterone hormone. So this is called as corpus luteum, and later on if no fertilization happens, this will turn into scar, so it is called as corpus albicans. So these are the different stages of Graafian, that is follicles. Female follicles, that is inside the egg will be forming by one like this process only. So because of these follicles, this cortex is so denser and granular, and the inner part is medulla. Medulla will consist of lymphatic vessels, blood vessels, and nerve fibers. Everything is present inside the medulla. And next so this area that is below the dense germinal epithelium, this part is called as tunica albuginea. And next one, this entire ova or ovary remain attached to the pelvic wall and posterior wall, that is back of our body. So and uterus by the ovarian ligament. So this ovarian ligament, that is meso-ovarium only, making the ovary and uterus is attached to our body. And these are all about the ovarian structure. And one more thing, this is addition, that is in our body, in the female body, the uterus is very strongest muscle. So it is a strongest muscle of human body. In addition to the structure of ovary, let us see certain important glands which is present inside the female reproductive system, especially near the vagina. So this is female reproductive system, we know already, and this is ovary, a pair of ovary both the side, and this ovary next followed by the fimbriae, finger-like projection, that is called as fimbriae, and this is called as fallopian tube. Here only fertilization takes place, and later on it take journey and it will reaching the uterus. This is uterus, this is womb for the baby, and reaching what happens after the fertilization, a baby fully developed, it will be come through the vagina. So this is the vaginal region, and this vaginal region will be having a secretion is called as Bartholin's gland. So it is a greater vesicular gland. This is what jelly-like gland. So it is present left and right side of the opening of vagina. So this is a common opening for the entry of sperm as well as the releasing of baby, full formed baby. So that passage, the right and left side of the vagina will be having this Bartholin secretion. It is similar to that of bulbourethral gland of male. And next one is called as Sneen's Skene's gland. So this Skene's gland is located anterior wall of the vagina as well as our lower end of the urethra. And this also said to be lubricant fluid. It is homologous to that of prostate gland of male. Next one is hymen. So hymen is nothing but that vagina opening is partially closed by the thin ring tissue. So that is called as hymen. So today, due to some activities like cycling, horseback riding, for these activities, so it cannot be considered as an indicator of a woman's virginity. So it may have the chance, the female may having the chance of a torn due to the sudden activities like this. So this is called as hymen, a special ring-like thin tissue which is present in the vagina. And next one is mammary gland. So this mammary gland is a modified sweat gland for both the sex, male and female. And this mammary gland having the following structures. So if we see in detail about the mammary gland. So inside the mammary gland we can find more than 20 to 25 lobules. So these are all lobules. So these lobules consist of lot of hair-like structure. Okay, this hair-like structure is called as main area alveoli, said to be alveoli, and this is the area of milk secretion. And these alveoli are united to form the lobules. So these lobules, here more lobules are found. These lobules are connected to form a tube-like structure is called as mammary tubule. So these mammary tubule are connected to form mammary duct. And we can find lot of mammary duct here, and these mammary ducts are united to form the mammary ampulla. So it is bulging in shape. Then this mammary ampulla later on connected to form the lactiferous duct, and this lactiferous duct directly opens in the surface of the nipple. So and this area, the area surrounding the nipple is called as areola, so which is dark in pigment. If baby sucking this part, it get the milk. So this is the structure of the mammary gland. So this is a lobule-like structure which will be having the alveoli, that milk secretion area, and then it is connected to form the mammary tubule, and these mammary tubules are connected to form the mammary duct, and mammary duct are connected to form the mammary ampulla, and mammary ampulla leads to lactiferous duct, and it is opening on the surface of the nipple. And maximum this breast development takes place or starts at the puberty, and during the menstrual cycle lot of progressive changes can be seen. And for the non-pregnant time, the breast is large due to the underdevelopment of certain glands, that is milk secretion, and it is large due to the fat deposition. So see, these are all fat deposition, and these are also fat deposition. And next one, so we cannot find any lactation secretion during the unpregnancy time. So only after the pregnancy, after the parturition. Or what is parturition? It means during the delivery time it causes pain, or after the delivery only, immediately after the delivery, these alveoli will start secreting the milk and it ejaculate outside. So this is called the mammary gland of female. And next one is spermatogenesis. Spermatogenesis means sperm production. So it takes place inside the testes, inside the seminiferous tubules. So when we taking cross section, we can see the structure. So if we taking a longitudinal section of the crossed seminiferous tubules, you can find the structure like this. So this will be Sertoli cells, and this Sertoli cells will be having the capacity to produce a sperm. So this is spermatogonia, and this is spermatocyte, and this is spermatocyte 2, spermatid and spermatozoa. So this germinal epithelium of the seminiferous tubule having this Leydig cells, and this Leydig cells only producing the sperm. Let us see how it takes place. And one more thing, so from the Leydig cells, once all the sperms are formed, it comes out and reaching the lumen. This process is called as spermiation. So this process is called as spermiations. And next one, let us see how the spermatogenesis takes place. And this is a matured sperm. And for the spermatogenesis, some hormones are very important. That is, it is stimulated by the hypothalamus. Where it is located? It is present in the brain. So brain having the hypothalamus, that hypothalamus is divided into two parts, is anterior and posterior. So in hypothalamus, the anterior part of hypothalamus will be secreting the gonadotrophin hormone. So that gonadotrophin hormone, whereas two types, they are called as follicle stimulating hormone and luteinizing hormone. This follicle stimulating hormone from the anterior part of pituitary gland, it reaching the serotolase cells. You know where it is located? So yes, it reaching the serotolase cell, and inside the serotolase cells it producing the inhibiting, because if the hormone is secreted more, this will go back and it will make the anterior pituitary to stop the secretion of the follicle stimulating hormone. And if it is less, it will make, or this is called as feedback mechanism by the inhibin, and remaining will go on production, involving in the production of spermatogenesis. And the next one, there is Leydig cells, it luteinizing hormone from the anterior pituitary reaching the Leydig cells, and it producing testosterone hormone, and this testosterone hormone having the major function of production of spermatogenesis. So this is called as the, so here this also will doing the feeding back mechanism, and these are the hormones which is involving in the spermatogenesis. And next one is spermatogenesis. We will see the process one by one. So in seminiferous tubule, the germinal epithelium involving in the sperm production. So first the germinal epithelium start dividing mitotically. So mitotically, so here mitotically it will divide. So that phase is called as multiplication. So the spermatogenesis having three phases. One is multiplication phase, next one growth phase, and then only the time the maturation phase. So up to this is called as multiplication phase, and here it is called as growth phase, and then these are said to be maturation phase. So due to mitotic cell division, one cell, if we take one cell in the epithelium, germinal epithelium. So here I am going to say what is germinal epithelium. So in our body, two types of epitheliums, that is outer layer is said to be epithelium. Two types of cells are the epitheliums are there. Germinal, which is present in the reproductive organ. So that's why it is said to be germinal epithelium. And one more is somatic, it is present in the remaining body part. So here the germinal epithelium, if we take one germinal epithelium, it will undergo mitotic cell division. It forms four spermatogonia. So these spermatogonia will be also having the two end, that is diploidy. So if this cell having 46 chromosome, even these four cells also will be having the 46 chromosome, and later it will undergo the so here these in this stage it will be these four cells, the four spermatogonia can be divided into two types. So some of the spermatogonia, half of the spermatogonia undergo again this multiplication phase and forming the spermatogonia. So that is said to be type A spermatogonia, and some will undergo the sperm production, so that is turned into type B spermatogonia. So type A spermatogonia, it never forms the sperm, it again and again multiple and form this primary spermatogonia only. But this one undergo type B only, undergoing the growth phase and maturation phase and forming the sperm. So this is type B. Under type B, so this spermatogonia will grow in size, and now this is said to be primary spermatocyte. So this primary spermatocyte also will be having water. This also will be having two, that is grow in size and forming two haploid. So here the diploid is converted into haploid. So haploid spermatocyte, primary spermatocyte is forming here. So this is primary spermatocyte due to the meiosis cell division, reduction division. So due to this process, this 46 chromosome is changed into 23 chromosomes. So after that, this is called as secondary spermatocyte. This secondary spermatocyte again involving in the second meiotic cell division, that is reduction division. So then it forms the spermatid, again the oval shaped spermatid with a haploid. So from one spermatogonia, here 4 spermatids are formed. So these spermatids again differentiated into sperm-like structure, that is small worm-like structure. So this is called a sperm, and this conversion of the spermatid into spermatogonia or spermatozoa or sperm, this process is called as spermiogenesis. This process is called as spermiogenesis. So during this process, what happens? Lot of changes will take place inside the nucleus and remaining part of the sperm. So let me see one by one what are the changes takes place inside the or in the chromosome, that is in the sperm. So first one, inside the nucleus, that is this is head part and neck part. We will see in next video. This is in head part, it has a nucleus. That nucleus will be condensed due to the loss of RNA and acid protein. So because of the condensation, only it contains DNA and basic protein, and due to this it will change its shapes. So pointed end, anterior part, and oval flat like structure it attains. And here inside this, the Golgi body also divides into two. One is acrosome, another one is Golgi rest. So acrosome is having a major function to forming the sperm lysis. Do you know what is sperm lysis? So this sperm lysis only, this acrosome only help the sperm to digest the outer wall of the egg during the process of fertilization. So that is the function of the sacrosperm. So it is otherwise it will be sperm lysis. And next one, the entire structure of the sperm is covered with a plasma membrane except the tail part. So head, neck and middle part, everything is covered with plasma membrane except the tail part. And because of that, the tail will be having the cytoplasm. And next one, in this sperm, we can find the mitochondria, spirally called mitochondria. They are called as Nebenkern. So these are about the spermatogenesis. So spermatogonia, and next one is primary spermatocyte, and this is 46 chromosome, and this is also 46 chromosome. It will be undergo first meiotic cell division and forming 23 haploid secondary spermatocyte. Again it contains secondary meiotic cell division and forming the spermatid with haploid number of chromosome. Again this spermatid will be differentiated to sperm-like structure is called as, this otherwise called as spermatozoa or sperm, and this process is called as spermiogenesis. Next, let us see about the structure of sperm. So, sperm is a haploid, flagellated, motile, single cell. So, think whether this sperm is a single cell or multicellular. So, this sperm is a single cell because it is forming from the single spermatozoa. So, this is a single spermatozoa. So, it is a unicellular only and a large unicellular in the human body. And this haploid sperm having the 4 different parts. So this is called as head part, and this is neck region, and this is middle piece, and these are all tail. So maximum the tail function is only for swimming. So this tail helps the sperm to swim and reaching the female. That is the only function of the tail. So this is head part. So head part consists of 2 things. One is nucleus and one more is called as acrosome. So you know what is acrosome? Acrosome is formed by Golgi bodies. So Golgi bodies, you know what is the function, where it is located. So you learn while you learning, there is animal cell and plant cell itself, you know what is Golgi body. So that Golgi body only forming the acrosome. So this acrosome, already said, this is a spermiolysis. So this acrosomes, while the sperm reaching the egg, this acrosome will make a penetrate and make a rupture the or digest the ovary, that is egg wall. So that is called a acrosome. So the head consists of 2 parts. One is nucleus, another one is acrosome. This nucleus, the anterior part is bulged, and posteriorly we can find the depression. So this depression is the place we can find 2 centrioles. So one is proximal. The first one is called as proximal centriole, and next one is called as distal centriole. So this proximal centriole will forming the spindle fiber during the cell division and during the zygote division, and later on this distal centriole forming the axial filament, so which will start from the neck and reaching until the complete tail. So that axial filament, while we taking cut, we can find the filament 9+2. So it start from the distal centriole only, and then the middle piece we can find the mitochondria, which is spiral in shape. You can see this one. So spirally coiled mitochondria is located in the middle piece. Because of this spirally coiled mitochondria, it is said to be Nebenkorn. And next one, the head and remaining part, head and middle part, neck part, everything is covered by the plasma membrane, and except tail. So the tail is covered by the cytoplasm. And one more thing, there is a membrane in the anterior head part. So that membrane is called as galleae. So here, from here to here, we can find the membrane that is called as galleae. And one more thing, the posterior head will be having up to the middle part. So that membrane is said to be manchete. So from posterior head till the middle piece, that is called as manchete. So there are two membrane. So one is present in the anterior part of the head and one more is present in the posterior part of the head. And next one, so this sperm are two types. So some will be having X chromosome. Half of the sperm will be having X chromosome and half of the sperm will be having Y chromosome. You know what is X chromosome? It is a sex determination chromosomes. For if we take 46 chromosome, out of 46 chromosome, 22 pairs are body chromosome and only one pair, that is only one pair is said to be sex chromosome. That is here sperm will be having, half of the sperm will be having X chromosome and half of the sperm will be having Y chromosome. If the sperm having the X chromosome, then it is said to be gymnosperm. If the sperm having the Y chromosome, then it is said to be androsperm. So only the sex determination is done by the sperm only and not by the female. So maximum female egg will be having similar type of chromosome, that is all will be having X chromosomes only. If X chromosome of the sperm combined with the female, it forms the female baby. If Y chromosome of the sperm fused with the egg, it forms the male baby. So sex determination is only done by the sperm and not by the female. And next one, the viability of the sperm, that is it will live, it survive more than 2 days, but its capacity of fertilizing only 24 hours after the releasing from the seminiferous tubules. So that is the viability of the sperm. Thank you.